Today we're going to be talking about the standard deviation and normal distributions in the stats unit for Algebra 2. So what is the standard deviation? Well, the standard deviation is the typical distance that a point is away from the mean. So the typical distance a point is from the mean. So what is that going to represent, say, like on a graph? So like, why do we even need to know the standard deviation? Well, there are some problems that you'll see that it comes in pretty handy. So here's the chart I want us to look at. You can see that it's quite interesting, just accounting for the data and stuff. But basically, this is your standard deviation, right? And so your mean here is at 0 because it's at 50% of the data. You can see how it's like symmetrical, right? It's like a parabola and it's symmetrical in the middle. And so within one standard deviation, you're going to have 68% of your data. Like your total data, the number of values is going to be 68% accounted for within one standard deviation. And that's going to be a very similar pattern for, say, two standard deviations. And so two standard deviations is going to be these two benchmarks, and that is going to account for 95% of the data. You'll see this decreasing pattern is because most of your data is going to be centered towards the middle because standard deviation accounts for variability. And so since most of your data is actually in the middle, the farther you go out by the same standard deviation, you're going to account for less of the data. And you'll see that for the third standard deviation, you're accounting for 99.7% of the data. Okay, so how do you apply standard deviation? Today, we're going to be looking at normal distributions. So what are normal distributions? Well, normal distributions have this set of, like data points. So this is 68%, 95%, 99.7%. That applies to normal distributions. And normal distributions have this symmetrical parabola shape, as I've talked about before. But there's also another way you can calculate it. So let's say we had a set of data points. Let's just use something simple like 1, 2, 3, 4, 5, and we want to calculate the mean. So 5 plus 4 plus 3 plus 2 plus 1, divide that by 3. That's going to give us a mean of 3. So our mean is 3. Okay, that's useful to know. Now what we want to do is find the distance every single point is away from the mean. So let's list our data points again, 1, 2, 3, 4, 5, and just subtract away the mean to find the distance in between them. And that's going to give us a very interesting pattern, as you'll see. This gives us -2, -1, 0. Nope, it's not writing. -1, and not -1. +1. 4 minus 3 is +1. So the 2's cancel on both sides, the 1's cancel on both sides, and we're just left with 0. So we can write, let me change colors real quick for this. We can write that the sum of x minus x with the symbol over it, this represents each of our data points, right? Each of our data points as x, and this right here is just the mean. It's going to be equivalent to 0. So that difference for each of the points, the sum of that, the sum will be 0. Now, if it's approximately normal, you're not going to get 0, but relatively a close number to that. So let's move on to a practice problem just to explain my thinking and how you're going to be approaching these problems. So let me change colors again. Let's use green this time. All right, so scores on the critical reading section of the 2011 SAT reasoning test, interesting, haven't heard of those in a while, are approximately normally distributed with a mean of 497 and a standard deviation of 114. Sketch the distribution with a scale on the horizontal axis. Okay, so let's just make our graph because it wants us to make a scale in that distribution. So we don't have to label the y-axis, although it's probably helpful to, but we can't really tell based on the values. But what we can do is label the x-axis with the standard deviation values. So if we draw our relatively symmetrical, that's not a great drawing, but basically you want something similar to like a bell curve or symmetrical in the middle. we know the middle right here is going to be the mean. So the mean right here is 497. And then we want to write our first standard deviation, second standard deviation, and third standard deviation and represent it on this graph. We know the standard deviation is just 114. So within one standard deviation, 497 plus 114, 497 minus 114. And so that's why we're going to have these 2 points, which is going to be 383 here and 611 here. And we're just going to do the same thing with a second standard deviation and a third standard deviation. So the second standard deviation is going to be 269. This one's going to be 725. Over here is going to be 839. And this one's going to be 155. All right, perfect. Now let's actually move on to the questions. All right, so actually I want to start with this one because it's labeled number 1. So what percentage of students scored between 383 and 611 on the critical reading section of the SAT? Let's look at our graph because that's the reason we drew it, because it's going to help us visualize the problem and answer it correctly. So if we look at this problem right here, it's going to be really interesting. We have a value of, 383 and 611? So 383 and 611. How magical is that? And this is, as we know, represents the first standard deviation. So we're looking at everything in this range here. I don't know why I deleted my stuff. But anyways, that's going to be everything in there. And so if we look at the chart that we had back here, we know that within one standard deviation is going to be 68%. So let's just write 68% nice and big there. And move on to the next problem. So what percentage of students scored over 611 on the critical reading section of the SAT? This is an interesting problem. So let's just refer back to what we currently know as the standard deviation, right? So we know everything in between 383 and 611 is going to be 68%. But what we also know is that 497 is the mean, right? And the mean is going to be 50%. So what this means is everything over here is going to be 50% of the data, 50%, and everything over here is going to be 50% as well. So if we want to find the percentage of students that scored over 611, let's just take what we already know. The first standard deviation, which is 383 to 611, is going to be 68%. So if we take half of that, we're going to get 34%. And this is a very interesting pattern because that represents everything here. And that represents all of this right here, if it'll let me write. And we know this side, everything under the mean is 50%. So all this is 50%. And so now we just have 50 plus 34, which will give us 84%. And that's not our answer because we want the percentage of students who scored over 611. So 84% is everything under 611, right? And so if the total is 100%, we can just subtract 84%, which will give us 16%. All right, that was kind of clunky because I'm having some technology issues. OneNote is not being very efficient. But let's move on to the next problem, shall we? So what percentage of students scored less than 269 on the critical reading section? So let's mark 269 on our graph. And we know that 269 is within 2 standard deviations of our whole set of data along with 725 on the other side. So this entire thing encompassing is going to be 95% because remember about our chart above, everything within 2 standard deviations, 95%. And so you might think, 100 minus 95 is 5%. No, because listen, we're looking for everything under 269, but the problem is we still have this little space here for the other side. So this is also going to be a part of that 5%. But like I mentioned earlier, since this is a normal distribution, right, it's going to be symmetrical. So if this side right here is symmetrical to this side, and we know everything in between is 95, and we have a total of 100, so let's just write 100 because that's our total, and we subtract 95, and so we have 5% just sort of distribute between those two parts, and since they're symmetrical, they're going to have the same value. So 5 divided by 2 is 2.5%. That's going to be your answer. Another way you could have thought about this is that since this is 95, right? Since this is 95, and this was 2.5, 95 plus 2.5 is 97.5. And so 100 minus 97.5 is 2.5%. Man, I absolutely love the OneNote screen. It just writes so well. But yeah, thank you guys for watching. If you learned something, drop a like. And yeah.